Hello everyone, and welcome to another complimentary Greentech Media webinar. This webinar is part of a series of webinars that we do throughout the year to keep professionals in the grid modernization market informed through research and analysis on the latest technologies and market trends. Today's presentation, The Next Evolution of Demand Response, is brought to you with the support from our sponsor, Enbala Power Networks. I'm Omar Saadeh, a Senior Analyst at GTM Research, a Greentech Media company, and I'll be moderating today's webinar. Greentech Media is an online publisher for information on green and renewable technology. GTM Research is the market analysis and consulting arm of Greentech Media. You can stay informed by reading the news on greentechmedia.com and find out more about our research products by visiting gtmresearch.com. You can also click on the GTM icon at the bottom of your screen for more information on our company. Before we get started, I just wanted to take a brief moment to go over the screen in front of you. You'll notice that there is a dock along the bottom of the screen with several widgets, including one titled Download Slides, which is a link to download the PDF of this presentation. There's also a widget that allows you to share the webinar through your preferred social media outlet. On the right side of the menu bar, you can also find speaker bios. Please note that you're able to enter questions at any point throughout the presentation in the Q&A box located at the lower left-hand side of the screen. We'll be holding a 10 to 15-minute Q&A segment at the end of this presentation, during which we will try to address as many of your questions as time permits. So I am truly delighted to be joined today by today's speakers, Michel Losier, who is the PowerShift Atlantic Program Director at New Brunswick Power, and Bud Voss, the President and CEO of Enbala Power Networks. Today's presentation will be broken up into three parts. During the introduction, I'll cover some high-level insights into GTM Research's ongoing coverage of the distributed energy resource management software market, based largely on several recently published reports. Following that, Michel and Bud will discuss how the traditional utility demand response market is transitioning to a more encompassing concept, toward the more encompassing concept of DER management. We'll be diving into one of the more progressive projects, PowerShift Atlantic, to get a better understanding on how a utility is able to leverage existing demand-side resources to help integrate transmission-scale renewables. And finally, at the end of this presentation, we'll have 10 to 15 minutes of audience-submitted questions. Once again, you can enter those questions in any time via the Q&A dialog box. The traditional centralized unidirectional electricity grid was built so that power could be produced at large central generation plants located upstream on regional feeders. It employs complex transmission networks to transport energy over large distances toward what's often been seen as predictable load centers. Voltages step down primarily at primary and secondary substations, enabling distribution networks to transfer power to local areas. In recent years, however, the increased proliferation of renewables and DERs has caused significant complications in terms of power flow management and reliability. Consequently, various integration techniques have seen accelerating adoption, particularly in the utility space in regions around the world. Localized strategies have been implemented in addressing limited areas, often characterized by high concentration of DER. Microgrids and siloed demand-side management coordination programs currently are more prevalent in North America and island grids such as Japan, and increasingly seeing utilities and behind-the-meter customer traction. However, such solutions can be seen as limited as they don't address regional utility system objectives, nor in general allow wholesale DER market participation. As grid operators are faced with a high renewable and DER future, associated distribution grid challenges have to be addressed with larger scale jurisdiction-wide solutions. So what is a distributed energy resource management system? In general, a DERMS solution is a software-based utility solution that increases an operator's real-time visibility into its underlying distributed asset capabilities, enhancing the operator's level of control and flexibility to manage distributed resource. While today's technology solutions may drastically differ in terms of underlying technology as well as specific use cases, this slide serves to outline some of the major functionalities promoted by a DERMS platform. When we consider the utility market space, DERMS is in its nascent stages. Vendor solutions have significant foundational differences. This creates a really interesting dichotomy, especially for an analyst like myself. Some solutions have essentially been deployed to support a utility's DMS, while others address specific applications such as facilitating a utility's DG interconnection process or managing demand-side resources to offset large-scale renewable generation. That being said, much of the underlying drivers are quite similar. Utilities interested in DERMS often face a high level of DER penetration, lack adequate visibility into their lower voltage distribution grid, and don't necessarily have the control and market platforms to effectively address both grid and behind-the-meter DER. A handful of North American utilities, mostly in California, BPA's territory in the Pacific Northwest, Hawaii, New York, and in the Canadian Maritimes, are currently developing and even operating some of these DERMS systems. Granted, these solutions are extremely custom. There's an overwhelming tendency, especially in the North American market, to focus on leveraging aggregated demand-side management resources to address capacity and ancillary needs. That being said, we've noticed a significant uptick in utility interest to invest in such solutions today. California IOUs, New York utilities, especially as DERMS is referenced in the REV DSP Market Design Working Group, and recently Massachusetts, where utility Unitil expressed its long-term intentions to deploy such a platform. One quick note here of emphasis is that much of the North American deployments do concentrate on implementing a platform to enable rapid demand-side management of resources. The European market, however, has taken a very different approach, supported by major R&D programs like Grid4U, Horizon 2020, and many others. The development in Europe has mostly been centered around enabling greater supply-side DG market participation. And to further highlight how we at GTM Research view the North American DERMS market, I wanted to touch on our market sizing and forecast. Based on both an existing utility project base seen on the previous slide as well as current developments. At the end of 2020, annual utility expenditure on DERMS was recorded just shy of $50 million annual spend. Now, granted, that's not a lot, especially when you consider other investments in this domain that could dwarf this number. That being said, under our base forecasting conditions, we do predict that the market will more than double by 2018, exceeding $110 million in annual spend by utilities. As we transition from local solutions like microgrids and siloed coordinated programs, utilities will invest in DER management platforms that address their specific needs, whether that be support DMS functionality, address intermittency from bulk renewables, or create a platform for greater DER market participation. And with that, I'm excited to introduce Michel Losier, who heads up the development of New Brunswick Power's PowerShift Atlantic project, often seen as one of the more progressive North American DERMS deployments. Michel?
Thank you. Thanks, Omar. And thanks for joining us today. I'm speaking to an industry cross-section here, probably not unlike those involved with the PowerShift Atlantic project. There were multiple stakeholders involved and quite a collaborative effort. So it really takes all these different stakeholders to work together to come to where we've ended up with this project. So I guess in the past, customers have always told us as a utility, we want more renewables, we'd like less fossil fuel, don't raise rates, and keep the lights on. And they look at the utility to figure that out on their behalf, and that's really the desire for our customers. So as we go forward, what this project really talks about is customers as partners, new technology, new opportunities for wind firming, but really for bringing it all together. And solutions are no longer existing just within the utility. It's an end-to-end solution, and we've demonstrated some of that at a research and demonstration scale, which is what this is, and I hope to give you a good glimpse of that today. So how to integrate customer solutions? The big transformation here is really a shift from generation following load to load following generation. So what I'll provide today is a bit of an overview on the national and the Atlantic region context. More specific to NB Power, we're a vertically integrated utility, so it's coming from that perspective. We border Maine and Quebec, obviously Nova Scotia and Prince Edward Island as part of the Maritime Provinces, and we have 394,000 direct and indirect customers, and we're at about a 10.5 cent residential rate in our region. So what's unique about our region? I hope to illustrate that today. Why wind firming in our region? What does it mean to NB Power and our region at a global level? Project-specific goals, objectives, VPP and aggregation. We'll talk about that. Specific loads that we connected. A bit on the customer experience. Some learnings and an outlook going forward. So as a first step, when we look at the national picture, Canada's about 64% hydroelectricity and 15% nuclear, 15% conventional steam, I'd say around 2% wind, and will be approximately 4% in the next 5 years. But if you look at that footprint, it's actually a pretty good footprint on an international scale, and we have amongst the most competitive rates in the world. If you look at the top, the total electricity generated in 2012 was about 600 terawatt hours. New Brunswick's probably 14 and a half of that in specifics. We're starting to see uptake in solar as well. Moving on, the New Brunswick's electricity supply, where we are today with renewables, is in the order of 30 to 32% renewable. Our overall goal is to get to 40% by 2020. So an increase in renewables and a reduction in fossil fuel dependency is in our goals, but obviously we want to do that in a sustainable way, and really this project is part of a way to get there. And demonstrated some real potential going forward, but there's still more work to do in interoperability with virtual power plants, etc. But we were able to demonstrate at a high level that this works. When we look at the region, picture the Maritime region, really we got the three provinces bordering Maine and Quebec. We are a windy region as part of the and our wind penetration in this region is fairly high. We're looking at 7 to 8% for New Brunswick wind penetration, in the order of 10 for Nova Scotia, and I think it's in the order of 25% for Prince Edward Island. So relatively speaking, we've got a pretty decent wind penetration. We're well interconnected. We've got a diversity of supply. And if you look at the center of New Brunswick, we're looking at a peak of 3,100 megawatts in New Brunswick. Our peak demand is 3,100 megawatts. Our min would be around 900 to 1,000. And if you look at the whole region, the peak for the whole region is about 5,500 megawatts with a min of about 2,200. But a total wind penetration of over 900 megawatts. So on a minimum load day, we need new solutions to better integrate the wind that we have, and that's part of what this project is about. In New Brunswick specifically, we balance in the order of 500 megawatts of wind on a minimum load day of about 1,000 megawatts. So again, that can be a high penetration, and projects like this, PowerShift Atlantic, can help us better integrate the renewables. What's important to note when you look at the 3,100 megawatts of peak demand in New Brunswick, 1,500 megawatts, and this is what's unique about us, 1,500 megawatts of that is electric space heating, and 200 megawatts of coincidental peak is electric hot water heating. We also in New Brunswick have a hot water heater rental program. We have over 250,000 hot water heaters at our disposition that we see as potential down the road. So the key is, and what PowerShift Atlantic really was about, is how can we tap into this flexible load with new technology and engage customers and try to drive some end-to-end efficiency improvements and link this to wind. So that's a bit on the perspective of our region and why it's important to us. We look at the coldest day of the year, and this was last year. If you look at from an evening peak to a morning peak, that's about a minus 32 degrees Celsius. There's probably 4 to 5 feet of snow on the ground, and it's really cold. So people wake up and they turn on the electric heat. But we'll go from a peak of 2850 megawatts at supper time on an evening and down to about 2450 at around 2 in the morning. And within a 5 to 6 hour period, we'll shoot up to 3,100 megawatts. So we'll see a 700 megawatt spike on that peak over about a 5 to 7 hour period, which is pretty intense on the system. It also we have to run our oil units to meet these peaks, probably 20 to 30 days a year. So when we look at load and flexibility of load, like water heaters, and we start looking at what's taking place at that peak, like if we get interconnected load and the wind doesn't blow for 2 or 3 days, we need to be charging some of this flexible load off the peaks and into the valleys. So we're looking for multiple value packages from different types of load, and hot water heater could be one of them. So really driving from peak to valley, and looking at the future as we get more and more DER and the potential with the DER we already have, how do we render a more effective end-to-end system? And PowerShift Atlantic has allowed us to think about that and start planning ahead, because the next 5 to 10 years we anticipate a lot more of this. So we're beginning with the end in mind, and we don't have it all figured out, but we're working at it. So again, offset the need to build, potentially reduce fossil fuel, and better integrate renewables. So again, that's a crude representation of a somewhat flattened load curve. If we look at the load of a typical house in New Brunswick, mostly electric baseboard heat in New Brunswick, many conversions are taking place right now to heat pumps, mini splits, and we welcome this because they're higher efficiency, and customers are looking for air conditioning. But we've also, because for the most part we have a lot of electric baseboard heat, primarily because it's the cheapest source for construction to put in. But customers are getting more savvy and are looking for better solutions. We've also trialed thermal storage with this project. So obviously, if you look at the distribution of a typical home in New Brunswick, 61% space heating, 20% water heating, and then all the rest. So the target, there's a big target between water heating and space heating, anywhere from 70 to 80% of a typical household. So that's what we're focused on. So wind firming in Atlantic Canada, PowerShift Atlantic, it really is a 5-year research and demonstration project, and Enbala was part of this. There were other aggregators part of this. We've had a great project here, Natural Resource Canada Clean Energy Fund project, led by NB Power in collaboration with Nova Scotia Power, Maritime Electric and PEI, St. John Energy, UNB, and NBSO. Engage customers, new technology, and a regional focus with a broad end-to-end view of the overall system to say, how can we better integrate renewables? And maritime customers are really maritime customers. They're not all that different, and they were really pleased to see us working together. So the project vision and goals really determine if these shifting patterns in energy consumption through load shifting can enable utilities to more effectively integrate wind, cost-effective and reliable. How does it perform in sync with balancing and forecasted wind power? And really, the most important part is to understand the customer's role going forward and how we can engage them in a new experience with electricity and renewables, and to be part of this, which played quite nicely. So we'll talk a little bit about that as we go through. So 3 words describe PowerShift Atlantic: collaboration, innovation, and transformation. And I say that because what we have on the phone today is a cross-section of stakeholders in the industry. And I can't stress enough the importance of working together for common purpose and really looking at it from a high-level perspective as to what's the most efficient thing to do in a region or in a jurisdiction. And it varies and it's different. We have a specific case here in the Maritimes that we're focused on in New Brunswick. So multiple stakeholders, utilities, academia, suppliers, customers, policymakers, and regulators were part of this, and really working together and innovating together towards win-win solutions. I think primarily win for the customer and win for the utility and the overall system. Because if you look at NB Power, it's a crown corporation, and all our customers own us. So if we can render a better end-to-end system and keep a low effective rate because we're doing better work with our assets, and as well the customer's getting a win by being part of the overall solution, I think that's really what customers would want. Question is, how do we get it there, and how do we get the conversation there? And that's by collaborating. Innovation, we talked new technology, VPP, aggregators, interoperability, dynamic links, customers to generation. And really, it's a new lens for all stakeholders, and we really need to reinvent ourselves to get to these new out-of-the-box solutions. New business models will evolve. So innovation is not just technology, it's how as a company NB Power is going to evolve to get into this space in the future. What kind of things do we have to do to transform? Again, getting to transformation, generation following load to load following generation, from commodity provider to an energy services provider. How do we add value versus just sell electrons at a dollar rate? What kind of value proposition and experience are we trying to deliver for our customers? And really, customers are now at the center of this. So that kind of describes the bigger part of the project. High level, Participants, regional focus, NRCan, NB Power, we talked about that earlier, Nova Scotia Power, Maritime Electric, St. John Energy, UNB, and NVSO. Really innovating together and leveraging one another's strength, utility to utility, utility to academia, and everyone working together with a solid governance. A very powerful experience for most of the people that participated in this project to really kind of leverage one another's strength and go after something that had a lot of purpose. Getting into the next phase, which will be of interest here, is really this virtual power plant. Traditional generation, conventional generation equaled customer demand. Generation followed load. I think most people understand that. And that's how the system worked in the past. For the most part, we had seasonality. We could forecast. Generation followed load. So now what's happening, we've got conventional generation plus wind generation equals customer demand. And we know that wind is intermittent and is creating some challenges, but generally those challenges are absorbed by the conventional generation system, whether hydro, gas, sometimes fossil fuel. It's more expensive, but it serves as a backup for ramping. So what we've done with this project is we said, okay, well, let's flip this equation and say conventional generation could equal customer demand minus wind generation, and we're going to do some load smoothing. So how can we leverage this load flexibility on the customer side to start taking up some of the fluctuations versus the generation system taking these fluctuations? And that's where the huge value comes in, is when we look at the large system and we really link from it, whether it's a local distribution company, back to the generation source. That's where the money is. And this is the real business case for this kind of thing, but it's really an end-to-end business case. And as a vertically integrated utility, we have the luxury of seeing it all. So day ahead, hour ahead, 15 minutes ahead, load forecasting, wind forecasting, and really trying to get some of this customer load to take up some of the intermittency with wind and variability. On to the next, virtual power plant. Really what we did here is we correlated wind forecasting to load forecasting. We've got aggregators as part of this project, interconnected with loads, and we'll get into some of that in the slides ahead with more specifics, but able to go both up and down with generation. Wind forecasting, day ahead, hour ahead, 15 minutes, so we have a continuous wind forecasting feeding this. Gross dispatch instruction going to the aggregators, and the aggregators then basically calling on loads to either go up or down. Space heating, building management systems with Enbala, water pumping systems through Enbala, HVAC systems, and also hot water heaters. So we're testing different load types. So this VPP is a custom platform built for aggregators with open standards, hosted in a cloud environment. It's really a research and demonstration scale. And we are working currently with our partner Siemens on a more robust intelligent load management system that would be more commercial grade, and that's undergoing right as we speak. We connected 1,400 customers to this and approximately 17 megawatts of load in total. So for the most part, the customers that were on the other end of this, they still had hot water, they still had heat, they still had their operations functioning the way they were supposed to. We just tapped into some flexibility that existed and connected it end to end. We also got about 15 to 20% at any one time of available load, total load, in the works of 15 to 20%. And we were pushing that to be aggregators to get a little more than that. So that's about where we ended up. Moving on, looking at the new supply chain really that we created with this project. It's a lot about interoperability. There are many new players, and there are many more new players showing up in this space between storage solutions and aggregation solutions that are happening through California and elsewhere. This supply chain is evolving quickly. So interoperability is under construction everywhere, and open ADR standards are evolving. Aggregators built interconnection to our open standard solutions, Stefus, Enbala, Integral Analytics, UNB. The project, I have to mention, was managed by Stantec and Acreon, who did fantastic work. Leidos was part of the design of the VPP. So the aggregators did some great work. But when they showed up, the aggregators, we had our open solution, and they all had their own solution that they were trying to position towards us. But we had to be specific to say, no, we need you to interface to our solution because ours is doing specifically what it's intended to do for the system. So it took a little bit of push and pull, but we ended up in a really good place, and we got a lot of good flexibility from the aggregators. Unique challenges, I think some of the learnings, there are unique challenges in every jurisdiction. Flexibility is required. Keeping customers whole, making sure we didn't interrupt customers, building interface, working with the utility, but the utility, we own the customers, and they provided, I think, a respectful technical solution, but also a nice intermediary with customers, so making them feel comfortable that this is a new space. It's important, and we needed to work with customers to make them feel a level of comfort with what we were doing, and I think collectively we managed that. So that's a big part. So many new opportunities are coming forward, and this will grow. But you see the end-use connectivity there as well. And hats off to, again, Stantec and Acreon for project managing, and our partner Enbala did a fantastic job here as well. Moving on, customer participation. I think that this slide speaks for itself, but customers were very open to participating. Now, when we started this project 5 years ago, that wasn't a given. And especially when you start saying we're going to take people's water heaters and heating systems and we're going to start shifting them. And I like to use the word shift versus control because people don't like the word load control. So the terminology we use as an industry, I think we need to be careful with that. Limited incentives. We did some co-branding and we provided $50 gift cards for residential customers. But for the most part, customers welcomed the idea of a renewable experience, and they were very open to us collaborating and working together as utilities and working in a region towards something purposeful. And that resonated well. And, for the most part, people say it's all about rates. And, yeah, it's about rates and it's about, being competitive. But there's also a feel-good feeling that more and more the new generation are looking for from the types of products they're buying or experiences they're having. With climate change taking place, and this played very well. So that may be an opportunity for us as an industry. Looking at some of the typical loads, connected loads and aggregation. If you look here, we had Steffes, we had thermal storage, building, EMS, HVAC systems, refrigeration, water pumping, and hot water heating. So going through here, we had in the order of 94 residential and 15 commercial customers for 1.2 megawatts with Steffes. These were varying sizes, but Steffes did their own aggregation as well and linked to the VPP. When we look at the next one down is the Dimplex unit. These were from Dimplex Canada, came from the UK. 138 customers, but 353 end devices, all interconnected to about a megawatt. That's a new solution for customers, and we went from baseboard to this heater. People kind of liked the type of heat. Interconnected through integral analytics, aggregated through integral analytics and into our VPP. And again, at the bottom we see those large units, Steffes. These are hydronic units, large water units. They're 80 kilowatts each, and there was one school where we had 400 kilowatts worth, so about half a megawatt in a school of bricks. Brick heating. So there's seasonality to some of this stuff as well. Moving on, you look at the Enbala, which Bud will elaborate on as well. HVAC, refrigeration, water pumping stations, but really some pretty sophisticated technical solutions for customers, kept them whole, and really brought more load than they had anticipated and got more flexibility out of the load that they had originally thought. Integral analytics and as well Enbala, obviously the aggregator linked to the VPP, and integral analytics, we had instrumented and non-instrumented water heaters as part of this project as well. So for the most part, again, for all these customers, it was business as usual, but all of these customers were interconnected to the VPP, and we would probably see 15 to 20% of load availability at any one time. Just a few pictures I'd like to go through here to show some of these, some of what we did. 60% of New Brunswick homes have what you see on the left-hand side is electric baseboard heater, going to electric thermal storage. A couple of things here is obviously it's a new form of heat. Customers had to get used to this because an electric thermal storage unit is not like a baseboard unit. There's a bit of an adaptation period. But storage heating, I guess it's one solution. But customers, one thing they would like is air conditioning with heat pumps and mini splits. So we have to find solutions that provide customers what they want. Perhaps thermal storage is part of the equation, but we're still working on that. So I guess at the end of the day, a lot of customers love this type of heat because it's actually a better distribution of heat than the electric baseboards. So that's just one view of it. We look at large thermal storage units in public buildings. This is potential for retrofits, where we've got, in this school, we've got 400 kilowatts, nearly half a megawatt of thermal storage available. It will require, we have to start thinking about new business models to make this kind of stuff attractive going forward. And in our buildings, this is leading by example. This is one of our schools in Woodstock where we literally have, these hot air units, brick units, and we leverage the flexibility in those. Great for peak shaving, and it's really about baking this stuff into the system as people go for retrofits and go forward. This has potential for us in New Brunswick with our heavy electric heating load. This may be part of a solution. So really what we're talking about here going forward is a new customer experience. It's when we found this out, it's really going beyond the commodity and pricing signals, better understanding what our customers want, who they are, segmentation, what drives them. And we have more work to do there, but we started to tease this out of them, like who wanted cost savings, what the importance of the environment, reliability, and also about a more of a renewable experience for our customers. So those things played well, but as an industry, we have a lot more work to do there. So how do we go beyond that commodity, make this attractive for our customers, and get to a better place? I think that's really, really important collectively. Again, one of the big things about this project, and I've said it many times, it's a customer project with technology. The technology is not to be underestimated, but for the most part, a lot of this technology could come together pretty quickly if we had an open spirit and really collaboration amongst many stakeholders working towards these solutions. So, and I think that's evolving, but there's much more work to do. It's a new way of thinking. But I'd say these projects, are 80% customer, 20% technology. And it's really different than the way we've thought about projects before, because as utilities, we've built technology projects for customers all through on our side of the meter. But now these are really customer projects with technology. So, it's a new partnership with new solutions, building trust and collaboration, looking for win-win solutions, and really, trying to find a way to improve the lives of customers and in turn drive overall efficiencies in the right direction. So how do we do that? And what, that's going to require innovation and new thinking. Storage solutions are evolving, and they'll bring tremendous opportunities, but how do we package all of that? And really, when we look at all of this, how can we optimize, the integration of DER as we go forward to get more of this? But the more important piece here is how do we earn the right to business growth? Because if we as a utility are going to expand our offering to customers beyond the meter in order to become more connected with customers and perhaps drive new value propositions and new growth for the company, how do we earn the right to that growth? And that really means that everything we do, we need to build more trust. So that's some of what we did. We started to do with PowerShift, but it starts us thinking about that in the future. So looking at the co-branding and the thank you program, some of what we did, it's a new look and feel. For some of these customers, they were just glad to be part of a wind integration project and to be able to put that as part of their corporate social responsibility. And that's going beyond commodity and price and really adding value in people's lives or companies' lives. Municipalities were very excited about this, and towns to be able to say they were part of this project. So there's importance there, and we're driving this renewable experience, and that has a level of importance. So, trying to provide this new look and feel felt good for people. Looking at the future, I think, before passing on to Bud here, the past, as a vertically integrated utility, we spent much time on the bulk system. We were monopolies, captive customer, potentially, a little more passive. But, this conversation is shifting, and, customers have more options and choices. We have climate change, competition, technology is evolving, and there's new DER solutions I think are going to need to be integrated and optimized, and basically end-to-end optimized, because there's a way to do this so it's better for everybody. And again, as a vertically integrated utility, it just makes too much sense, and we're having a lot of discussion with Siemens on that to say, how do we optimize this so that it's best for everybody in New Brunswick, customers and owners of the utility as owners. So again, we managed to connect 1,400 customers in a dynamic system here. And, really we're looking at probably a 30, 40, 50-year transition. I mean, bulk generation continues and will continue to be important, but we're going to see a gradual reduction of fossil and a gradual increase in renewable integration. But these two ends have to work collaboratively, and there's got to be someone in the middle that's thinking about what does this really need to look like, and how can we better guide this thing or steer this thing, understanding that we don't have full control on this one anymore, because customers are now getting solutions from the marketplace, and they will be driven into certain directions and are open to new ideas and sources. So as an industry, we have to get moving to really create that environment that gets us to the right place. So it's going to take some time. I think PowerShift was a little bit of an example of a start to that, but again, it's only a start. So I'll get Bud to pass a few slides, and I'll wrap up there towards the end. So Bud, off to you.
Fantastic. Thank you, Michel. And I want to acknowledge the great work that you and the whole PowerShift Atlantic team did on this entire project. In fact, I think it's well understood and known now throughout the industry what an innovative approach and capabilities, frankly, that your team has. And it's really why you were recognized by Greentech with your Grid Edge Top 20 Award, and I think continue to get accolades throughout the industry. Frankly, we're just proud to be part of the project. I'm going to ask Brady to actually advance the slides for me, and if he could please just bring up the first Enbala slide. And what I'd like to talk about here from an Enbala perspective is importantly what it takes when you go into building a system such as this. And you've heard Michel talk a lot about the role of the aggregators in this program, and Enbala was one of those aggregators. It's fundamentally important that when you build out a system like this and that you're trying to control and operationalize these types of loads, that these fundamentally three fundamental components. The first is built around the ability to do asset control and forecasting. As you can hear by Michel's the description that he described of how this program actually unfolded, it's a sophisticated software platform that is needed in order to do very precise control and forecasting of each individual asset. On top of that, not only do we control the asset, we then have to layer in optimization software. The reason why we need to optimize the resources themselves is fundamentally not only for the customer, and you heard Michel release the customer 186 times, it's because we're trying to operate within that customer's constraints while also trying to intelligently control these resources for the need of the grid and for the need of the grid service. Which brings me to the third point, which is then aggregating all of that together and providing a solid, robust network operations view and aggregation of the entire system so that we can deliver a reliable grid service, such as, in this case, firming of that renewable resource or an ancillary service or other wholesale market opportunities. It is truly a different world that we live in. It's why the title of this webinar is, I think, very appropriate about the new demand response future and what it is we're actually trying to build. Because when you put these three components together, control and forecasting, optimization, and then aggregation and market operations, it's not 1 + 1 + 1 = 3. It's 1 + 1 + 1 = 12. Because now you have a fully reliable and robust solution that is a continuously operating product that can be used for these types of programs. Brady, if you could just advance to the next slide, called the network effect. And Brady, I'm going to ask you to go ahead and bring up a number of the animations in this slide, because what it's showing you is when we put this all together and we have the capabilities that we do in the software that we provide, is that what we're doing is we're aggregating and we're bringing all of these resources together to match that very complex shape shown in red. That red shape in that red line shown on the bottom of the screen is a true grid service signal that's been sent to our software, and we have to respond to that. But you can't respond to that signal with one single asset. You cannot respond to that signal with only one or two. It actually takes the coordination and orchestration of all of the assets throughout the entire network in a very customer-constrained way in order to make sure that you can then deliver that grid service. And I'll ask Brady to complete out the picture and show how all of the network resources come together to actually match that red line. That is the power of the network effect. We are able to take through the collection of very, very small collection of resources and actually aggregate them to create a very powerful result. That is the fundamental component of being able to optimize and then control the entire network of resources. And again, in this particular program, it was a highly complex orchestration that was needed to be done between a series of both commercial and industrial customers, their large assets and resources, as well as the signals that were coming to us to firm that renewable resource. So let's talk about some of those results. And Brady, if you could go to the next slide. As we think about the PowerShift Atlantic program and specifically the work that we did with New Brunswick, it's important to note that as Michel showed you the statistics of the number of megawatts that we actually brought in, it's important to see that this was actually made up of over 2,000 individual devices on just the Enbala portion directly. We had everything from schools to water pumping facilities, some office buildings, and other kind of commercial and industrial loads. But this is 2,000 individual devices being controlled in real time and being controlled 24/7, 365. This is a continuous product, and I can't stress enough how important it is to think about this as a continuously dispatchable resource that's continuously moving, but yet also operating within the constraints of the individual customer. We're never pushing temperatures over a particular customer's constraint. We're never moving water too fast or too slow. We're never holding back any other industrial processes. In fact, what we're doing is we're simply coordinating the activity of this vast network of resources so that we can actually match that grid signal. And that's the power of the network effect and the power of the Enbala software. If we go to the last slide, which has just a few short animations on it, I will ask Brady to just bring up the first one, because this is important to see the actual results of the system itself. And the signal that's being delivered to us by New Brunswick Power and through the PowerShift Atlantic program is actually that sawtooth graph that you see there. That sawtooth graph is actually an energy target. This is a plot of megawatts versus time, and we're showing here about a 4-hour segment of time. Every 15 minutes, the Enbala platform is receiving an energy target, which is a very important aspect to this program because we're actually optimizing for energy output. We're not optimizing for power. And again, this is a continuous dispatch type model. Brady, if you could just click the next one, you'll actually see 2 yellow lines that emerge, and those 2 yellow lines represent the flexible range of all of the assets within the system. The Enbala platform is actually communicating this back to PowerShift Atlantic and their system. We provide this as a forecast basis, and we actually are showing what that flexible capability is of the load side resources that we have under control. So you see a high limit and a low limit representing the amount of load that we can manipulate within all of these different intervals. This is a very intelligent learning-based forecasting algorithm that is being used to communicate back to New Brunswick what we're capable of doing, but it's also being used to plan our coordinated control activities, which if you do the last click on this slide, you'll see an orange actually pop up. That orange line is the performance of the entire system on an ongoing basis every 4 seconds, in fact, you see us moving the power set points of these assets. And we're never operating outside any of the constraints of the customer. And we're also making sure that we match the energy target shown in green, which should be actually the last click, Brady. Shown in green, we're actually matching the slope of that line and the endpoint that's been delivered to us in green, showing that we're delivering the optimal amount of energy on every single interval as we have been instructed to do. And we're doing that through this ongoing coordination and orchestration of the assets in the network. Before I hand it back to Michel, I will say that it's been an honor and a pleasure to work with New Brunswick Power and everybody on the PowerShift Atlantic program that's been involved. Frankly, I think Enbala and the entire team has been forging forward this new world of the evolution of demand response. And in this new world, we're going to find so many new edge-based solutions, from battery storage to renewable energy at the customer site to smart inverters to all sorts of proliferation of devices that are going to emerge, that it's going to take this new thinking, the thinking of using software as a network operating system that we can then use to manage, mitigate, and control all of these resources on a complete and ongoing continuous basis. Again, we look forward to a bright future with New Brunswick Power. We continue to work with them, and we are continuing to move forward with providing these innovative solutions for other customers as well. With that, I'll turn it back to Michel, and you can provide a very brief summary.
Thanks, Bud. And again, I think we also, working through Enbala, we had a working solution right out of the gate, respecting the relationship with the customer and leaving the utility continue to own that relationship, I think was critical. But bringing a solution that was ready to deploy and interconnecting and demonstrating the right flexibility. So I think that's reciprocal. I think we had a good overall project. Couple things just to wrap up. Look, the VPP at a research and demonstration level performed as intended. We had about a 15-minute ahead. We could tighten that up a little bit, but we chose to get at least to keep it broad enough so that we could better integrate renewables. And as we go forward, we'd want to tighten that up a little bit. Business as usual for customers. For the most part, really, customers wanted to know more. We need to evolve our conversation with customers with projects like this. They want to know what's going on. They want to know their contribution. And that's where, as utilities and stakeholders in this industry, we need to start that engaged conversation with customers more and more. They favored a renewable experience. Yes, there were no price incentives for this project per se, so we were very pleased to see the participation levels high. Utilities need to own the customer relationship and continue to own that. And I think aggregators bring great technology solutions, but we're going to have to work at that because it's the marketing piece and owning the customer relationship is one piece, but and the technology solutions, I think, as interoperability develops, will become more and more cost effective, and I think that's under construction right now, and I think Bud would agree with that. Upscaling will lead to cost reductions. Obviously, we've got 1,400 customers, but we have 250,000 electric hot water heaters here. Getting that price point for that electric hot water heater at the right place, getting a technology solution and a link into our VPP that's cost effective, I think that's critical. That is what we're working on today. And we're working at solutions for products and services to be able to drive this. These will become more competitive, but I really believe that customer edge solutions are the way forward. They will continue. This will continue to evolve, and we are working with Siemens on a long-term partnership to really take this forward and look at what is this next phase of ILM at a commercial level, a commercial scale, to really bring this home for New Brunswick. Really what this comes down to is how can we offset the need to build new generation, reduce our fossil dependency, and better integrate renewables. and ultimately, help our customers better manage bills, but deliver an enhanced experience and make their lives better all at the same time. That's the challenge for utilities. So, just in closing, I think many who participate on this project would describe this as a highlight in their career and working towards a purpose. I think that a lot would say it was a great experience, and I just hope this shed a bit of light on the project, PowerShift Atlantic, for folks. Thank you.
Great. Thank you, Michel. Thank you, Bud. I think that was a fantastic presentation. Really interesting project, specifically as we move beyond, again, the whole evolution of demand response, and we're moving to a more encompassing notion of aggregating DERs, both supply and demand, and with in the proliferation of even larger scale renewables. Such a solution is going to be of interest to many more utilities, I could imagine. Also, throughout this whole presentation, we've had really a large number of questions come in. But just as a reminder, we still have about 10 more minutes, so feel free. The audience can submit a few more questions through the Q&A box at the bottom lower hand corner. Kicking it off, there have been several questions of the whole notion of the role of the aggregator. Michel or Bud, I'm wondering if you could elaborate a bit on how New Brunswick Power communicates with aggregators like Enbala, and subsequently how they communicate with the resources, specifically highlighting the time scales involved for ancillary services and how those things are properly compensated.
Okay, Michel, do you want to address that first, the perspective of how you view an aggregator?
Yeah, I think the key here is the aggregators we had on this project. I mean, we provided like the constraints, like with the, I mean, everything's bi-directional, and we're looking at hour ahead, day ahead, hour ahead, 10 minutes ahead, and the ability to continue to understand, what load is available on an ongoing basis and forecasting. So I mean, I think we had some learnings along the way, and we used a SOAP, I believe. The technology was standard, was SOAP standard, and perhaps you can take it from there, Bud.
Yeah. So I think the role, we use the word aggregator in this program different than the term aggregator you might find in an open market scenario such as PJM or Ontario, where truly the aggregator is responsible for all of the load recruitment and all of the customer interaction, all of the customer service. In this program, I think highly different than most, we were viewed as a technology aggregator, and then we worked with and through New Brunswick to help recruit the customers, help bring the programs in, but it actually was not an Enbala logo that they were seeing. They were seeing a New Brunswick Power logo. They were seeing a New Brunswick Power program, and I think that's very important to also the future of how New Brunswick sees this program rolling out. So we were responsible as an aggregator for all of the technology deployment, the customer assessment, the customer audit, the engineering of that solution, and then actually operating that system against the APIs and interfaces that were given to us from the VPP, which included forecasting and then the actual control set points as well.
I just wanted a follow-up question on that, just from the high volume of questions that are in. Several relate to moving beyond R&D towards more commercial-grade systems. Is this a question of, and Bud, you bring up the whole notion of grid flexibility versus individual resources. Is this a question of price point? Is this a question of the required rate structures that have to be in place, or is this a question of technology?
Well, it's definitely not a question of technology. I think we've proven over and over in various markets, and not just in ballot trials, but other programs, that the technology can deliver these types of resources. It really comes down to establishing the correct metrics and then the value proposition that's given to the customer. I think here, with this specific case study, it's really important to understand that the value proposition was actually set very appropriately, and we got great customer participation, which gives me great hope for the future. And I think New Brunswick would say they have a very, very long-term vision of this becoming a very, very large-scale solution because they've got the value metrics set right for customers to participate. And I think that's going to be true in most of the markets that are around. This is not a technology question anymore. This is a question of how do we move beyond this kind of load shedding into a load shifting, or frankly, the new generation of demand response, and start building a value proposition around that for customers. And I'm happy to say that I think New Brunswick has that right.
Yeah, and I think to add to that, really understanding where value exists relative to how the generation system performs day to day, season to season, how the hydro system is performing, and really understanding, where is the value, and then correlating that to what types of loads and what types of products and services and offerings could we bring to customers that would make their day, enhance their energy picture, or perhaps their lives even, make their lives better, but create really business models that bring the two together. And there's more work to be done there, because as a utility, we're doing a lot of work right now to understand that specifically. We're driving a new products and services division to look at electronic thermostats, water heaters at the right price points, new heating solutions, and understanding how can these things come together. But how do we make this attractive to customers going forward? And that would mean evolving business models and working with multiple stakeholders, policymakers, regulators, et cetera, as we go forward to get to that new world.
Michel, I think that's an excellent step into the next question. It was just around the whole utility-customer relationship. Traditionally, the utility business model is focused on energy as a commodity. And this might, you might touch on several of these, but how does a utility address new customer demands of renewables and sustainability? And specifically, has this been done in New Brunswick where you're able to monetize those value streams?
Well, I think the biggest thing we need to do as a utility right from the base is obviously we're looking at going beyond the meter. I think as utilities, we've established a certain trust and credibility as a reliable, safe, relatively cost-effective supplier of electricity, environmentally responsible. But there are new options showing up for customers. So this next level of trust and really earning the right to growth on the other side of the meter, on the customer side of the meter, and finding new solutions, I think will require strategic partnerships. Some of it we can do on our own. We've got our water heater program. There are other products we can have on our own. I think it will be a combination. There will be some networking from a utility through perhaps a third-party supplier, getting that perhaps network brand to a customer going forward. But really, it's extremely important for us as a utility right now in everything that we do to build trust. And that goes right from vegetation management to keeping the lights on. The very traditional things that we do need to be spot on. And there are companies in the world that people rave about their products, and they earn the right for further business, and people sell them themselves. And as a utility, we have work to do to get to that level, but that's where the vision has to be if we're going to get to that new world of products and services. So, but again, so it's a work in progress, and we're working hard at that.
Michel, when you look at the demand response market in North America, it predominantly involves a lot of C&I players, especially as they are typically more flexible with their loads, given proper market signals that are in place. You mentioned this whole notion of shifting from generation following load to load following generation. How does that apply to maybe a smaller and more distributed residential DER? And how does a system like the one in place in New Brunswick Power scale to something that could be more widespread and distributed versus large-scale C&I customers?
Well, I think what the business case we did per se was, let's take a third of our water heater sample, which is about 83,000 water heaters, about 250 megawatts of water heaters. And with, that water heater at the right price point, which they're not there yet, and interoperability that's in the zone, that, a technology solution that I think we would need to come down a little bit. If we get up to 15 to 20% availability for load smoothing, we're close to break even when we run our Plexus models going forward. So again, this is not quite where it needs to be yet, but it's not far off. And when we start getting up scalability and more of these water heaters out there, water heater's great because it's 724, 365, and it's fast acting. So there are loads and there are specific loads, and for the customer, I mean, they're still getting hot water. So why wouldn't we do this? So, but as a utility, what we got to figure out is how do we make the customer's day with this and our day with this, and how do we make this go forward? So that's the best example I could see for like a widespread DER small-scale solution that we've put out there.
Great. And just a reminder again, there have been a ton of questions, a lot around security and the applicability of smaller localized solutions like microgrids and how they fit into that. Unfortunately, we are out of time for today's webinar. I just wanted to again thank everyone for attending and note that not to forget that we're archiving this in our events section at greentechmedia.com, and that you can register for more free webinars that we've done in the past as well as upcoming ones in the future. One more time, I wanted to thank both our speakers, Michel and Bud, and recognize Enbala as our sponsor. And with that, I hope everyone has a great afternoon and hope to see you guys next time.